Now that the key files in the database are mirrored, and now that it looks more like a real production database, I am going to guide you through a small section of the web-based tool that is provided with Oracle Express. The home page presents 4 sections, and I shall only take you to the administration section, but as the information that is provided is often economical, and as the number of things that you can do is limited, I'll also make heavy use of the SQL section. You can use this section or SQL Plus as you wish. I personally find SQL Plus more responsive, but output is more legible in the web interface. In both environments, you can save queries and run them again later. A remark about the interface: you can click on the label of the image, and it takes you to other menu pages. If you click on the triangle, cascading menus are displayed and you get faster access. So, let's have a look at storage in this video, and let's start with what is labeled as storage utilization. Space allocated is the amount of storage that has been put aside for storing data. Do you remember the files under the ORAData directory? That's where data is stored. But as you will see very soon, this figure doesn't tell the full story when you are interested by disk usage. What is available is, interestingly, bigger than the 4 GB you are limited to. The physical limit is not, of course, a physical limit. The only physical limit is the size of your disks. Actually, it's a license limit. If you store more than this amount, then you have to buy the standard edition or migrate to another database management system. As you can see, it's comfortably above the official limit, but on the other hand, when you consider that before having stored any single byte of yours in the database you are already using 13%, it looks fair. This is a very high-level view of storage. Let's now see the details. You will notice that apart from compact storage, it's all about viewing the status, not modifying anything. But you can change a lot easily with simple SQL commands that I will show you. Let's start with table spaces, but I must first answer the question, what is a table space? Whenever you create a table, its data will have to be stored somewhere on disk. You can specify where the data will be stored, not by specifying a file name or a directory, but by specifying a table space, which is an abstraction layer to which disk space is separately associated, either as one or several files, or sometimes raw disk storage. Even when you don't specify explicitly a table space, a table is always assigned to a table space by default. I'll tell more about it when I talk about users. But table spaces aren't only for tables. Indexes also need to be stored somewhere, and everything that uses storage must go to a table space. However, when you create a view, then you just store the text of a query, and it is stored in the data dictionary that has a table space of its own, system. If you want to know more details about how storage is allocated and used in an Oracle database, watch my video about Oracle storage. But if you have understood what I have just said, you don't need anything more for this video. In the real world, a table space is where an application stores its data. Developers don't care about files or location on disk or whatever. System engineers and DBAs take this in charge. However, table spaces are important for developers because Oracle allows you, for instance, to transport a table space from a database to another, which can be useful for consolidating data in a decision support system. A table space can be put offline, or be made read-only, and so on. When you list table spaces, here is what you see. Interestingly, the values don't quite match what we have seen on the other screen. One reason is that, for instance, the undo table space wasn't counted. It stores previous values when you modify the data, so that the change can be rolled back. %used makes a nice histogram, but it's a completely meaningless one because table spaces are set to grow as they need to. You are going to see more on the topic very soon. But even so, the 4 table spaces that are listed don't give the full picture. Let's switch to SQL and run this query against the dictionary view called DBA_tablespaces. You see that you haven't 4, but 5 table spaces, and this one wasn't listed. It's just a work area, but if you check the files in ORAData, you'll see that it has its own file too, and temporary storage isn't always negligible compared to the rest. So, if you want to really know how much storage you are using on your disk, it's better to check files, or query the Oracle Data Dictionary views. The views of the Data Dictionary give you the full picture. If you want to see what are the views available to DBA, you can query the dictionary view that lists them all. I'd better tell you from the outset, there are 499 of them in Oracle 10. Usually it gets worse as the version number increases, since new features mean new views. But it's not all. If you remember, in part 2 of this tutorial, I have queried some views called Vidal something. You have 398 such views. I'll just show you a very small sample from the data dictionary. If you are curious to know what is initially using space in the database, set the number of rows displayed to 20 and run the following query that counts tables in table spaces. I ignore indexes. The sys tables in the system tablespace are the actual data dictionary, the tables on which the DBA views are built. User system, not to be confused with the tablespace, also has a few tables that are related to internal database features. The flows and XDB tables are required by Apex, the application development framework that powers the administration tool. I'll talk about the other runners later, but there is another thing that is interesting here: the 175 tables owned by sys in the sysoaks tablespace. There is a component in Oracle that takes snapshots of key indicators in the memory every hour by default. Basically, it saves the current values with a timestamp in those tables. This component is called Automatic Workload Repository, AWR for short. Now, if you want to use the values that are collected, you must pay for the Enterprise Edition and buy a special option called Performance Pack. In other words, although you have a lot of views called DBA_ist in your database that present this data, you mustn't query them. Don't even think about it. But this is the reason why you may say sysoaks grow over time. If you are just beginning database administration, it may be a bit too soon for you, but I also have a video about monitoring Oracle performance that explains how you can have some very good performance analysis with little documented tools that are available and usable in Oracle Express. But let's now take a look at data files, and you see here a number of interesting things. All files are by default allowed to grow up to a limit that is specified here. This is why the % used that we saw before was basically meaningless. You will notice that sysoaks can grow pretty big, and that you are obviously expected to store your tables in 2 tablespace users, the maximum size of which looks familiar. You may also notice that the file associated to the temporary tablespace, temp.dbf, is missing. You can run the following query against the dictionary view to know not only its current size, but whether it can grow and how far. Here is the result. I told you at the beginning of this course that I should try to show you how Oracle is administered in the real life. In the real life, you don't create all your tables in tablespace users. To one application, you usually associate 1 tablespace, and very often you associate 2 tablespaces, because some DBAs are keen on keeping tables separate from indexes. That used to be important 15 years ago. It's much less true today, and 1 tablespace per application is okay if you want to keep things simple. Let's suppose that you want to use Oracle Express to power a website and that one of the key components of this site is a forum. What I want is a special tablespace to store the forum tables. First of all, I'm going to modify the file that is associated to the user's tablespace. I'm going to keep this tablespace, but just for some tests and demos, and I'm going to say I no longer want this data file to grow. Of course, if a table has to grow in a tablespace that cannot and is full, I will get some errors. Next, I'm going to create a new tablespace with a create tablespace statement that specifies the name of the data file. It can be in the same directory as the other data files or elsewhere, its size, whether it can grow or not, by default it cannot, and the maximum size. To comply with the license, I just need with Oracle Express to ensure that I cannot use for all my data more than 4 GB in all. If I check the tablespaces, I see that my new tablespace has been added. Part of the job of a DBA consists in ensuring that you don't run into storage issues, which result in error messages from Oracle saying that it couldn't allocate what it needed. Monitoring space is an important task. But don't be confused by allocated versus used. It's different. Allocated just means reserved. When you create tables in a table space, automatically some amount of storage will be put aside for them. You can report how much space remains in the table space to create other tables, or to let the existing tables grow. But it's quite possible that inside the space that is reserved for tables, only a small part is really used. All of this makes knowing exactly where you stand a difficult exercise. The compact storage option that you have seen in the menus doesn't compress anything, it just launches a background task that tries to reorganize data and deallocate unused storage. It's not something that you want to do often. There is a package in Oracle that is called DBMS Space and gives very precise details about how data is stored inside a table. You should read about it and use it to see whether running compact storage is worthwhile. In practice, even with data files that are set in auto-extend mode, one day you come close to running out of space. Then you have three options to increase the size of a table space. The first option is to modify the data file parameters so that it can grow more, in the limits of the license, and push the max size up. That's a kind of lazy solution. Another possibility is to give a data file a fixed but bigger size. At the moment you issue the command, Oracle grows the file and formats the new section. Many DBAs prefer this solution, especially when they manage very big databases. The problem with files that grow as needed is that you can never be sure that when they need to grow they will find the space required, because someone has used in the meantime for something else the space that you thought would be used for Oracle. Having fixed files also make easier to monitor space usage. The percent that is used is then really meaningful. A third solution is to add a new file to the table space, and in that case you use the alter table space statement. This may allow you to spread your IOs on different disks, or to have same-sized files that some people find more manageable. The files you add can be made auto-extensible if you wish. There is no good way or bad way to do it, just alternate ways. The best one in your case depends on the control you have on your disks, whether they are physical or virtual disks, and whether you are more comfortable monitoring storage usage at the OS level or within Oracle. What is important, though, is to be able to be proactive and monitor and predict trends, something I'll talk a little about after I have talked about user management.